Good day! So yung topic natin ngayon ay scaling transformations. So ito na yung last na geometric transformation na i-cover natin. Okay, so ano yung gusto nating matutunan ngayon? Una, i-define natin at aalamin natin kung ano ang scaling transformations. Tapos gagamit tayo ng software, syempre GeoGebra, para i-demonstrate yung scale transformations na yun. Pangalawa, i-illustrate natin siya sa coordinate plane. So parang may coordinates para makita natin yung effect nung transformation sa points, sa location ng points in the pre-image papunta dun sa image under the transformation. And third, meron kasi tayong tinatawag na center of scaling or center of dilation. Para sa discussion natin ngayon, i-restrict natin na nasa origin lang muna palagi yung center of dilation na yun. Yung tutulong sa atin ngayon ay si Father Ben. It's actually Father Ben Nebres. Isa siyang national scientist for mathematics. I think as of now, siya pa lang yung national scientist natin for mathematics. Okay, so scale transformations. So start sa definition, it's a transformation that will map our pre-image into an image na ipe-preserve niya yung shape like the isometries, but yung difference is hindi niya ipe-preserve yung size or distance between points. So, I guess in a technical way, ang pinaka magagamit nating term to explain that is measurements of any angles in the pre-image hindi magbabago. Kasi di ba yung angle, pwede mong i-zoom in, zoom out. The angle measurements don't change even if the sizes of the distances between points dun sa angle mo nagbabago. Meron din tayong special na term for scaling transformations na nag-i-increase ng size. We call it dilations. But that really is reserve sa mga nag-i-increase yung size. Scaling din naman kasi pag nililiitan mo yung size and we call those transformations contractions. Sa scaling transformations, sinasabi natin na yung pre-image at yung image similar sila pag hindi nagbago yung shape. Pag hindi rin nagbago yung size, like sa isometries, ang tawag natin doon congruent yung pre-image sa image. But here, sizes will change. So, andun tayo sa similarity. Similar yung shapes ng pre-image at ng image. Okay, when we talk about scaling, we talk about a scaling factor. And sa GeoGebra, para makapag-apply ng scaling transformation, kailangan natin ng scaling factor and a center of scaling or a center of dilation. Dilation yung term na ginagamit sa GeoGebra. But we should know that this just means scaling kahit contraction yung gagawin natin. So like I said sa introduction, ang ating center of dilation will be the origin. So may nakalabel siya doon na O. And you observe natin how the points in the pre-image are being mapped as we will change the scaling factor. So start tayo na si pre-image ay ayan. And kung ang scaling factor natin ay 1, edi syempre walang magbabago sa kanya. So a scaling transformation with a factor of 1 will just map the pre-image to itself. So yung points ng pre-image, negative 4, 1, pupunta lang din siya sa negative 4, 1. Parang walang nangyari. Okay, let's change our scaling factor. Gawin nating 1.5. Tignan natin yung dimensions ng pre-image. Yung kanyang length ay 2 units, yung kanyang height ay 3 units. Pagpunta natin dun sa image, yung kanyang length ay magiging 3 units. Kanina 2, naging 3. So nagmultiply tayo ng 1.5. Yung kanyang height ay 4.5 units. So nagmultiply din tayo ng 1.5 dun sa height nung pre-image na 3. So 3 times 1.5 is 4.5. Yun yung scaling na naganap. Kung titingnan din natin yung coordinates, so negative 4, 1, naging negative 6, 1.5. Nagmultiply din tayo nung k. So, negative 4 times 1.5 is negative 6, and 1 times 1.5 is 1.5. You should see that for all the other points, yung 4 na points, lahat ng coordinates, para ma-map siya sa image, minultiply lang natin ng scaling factor natin na 1.5. We increase our scaling factor to 2, so ganun din nangyari. Yung dimensions ay 2 by 3, naging 4 by 6. Yung coordinates natin, na-multiply lang din natin ng 2. Yung x and y coordinates from the pre-image papuntang image. If we change the scaling factor to 3, again, let's look at the dimensions. From 2 by 3, magiging 6 by 9. Na-multiply ng 3 yung dimensions natin. And yung points natin, pag yung center of dilation is the origin, ganun din, na-multiply lang din ng 3. So, negative 4, 1, mamamap sa negative 12, 3. Si C, negative 2, 4, mamamap kay C prime, negative 6, 12. So, we could formalize yung mapping and we'll call it D sub K. D for dilation, K is the scaling factor. It maps XY papunta kay K times X, K times Y. Tignan natin, paano pag less than 1, pero positive pa rin, yung dilation factor. Kasi kanina lumalaki yung image natin compared sa pre-image. Now we'll use a scaling factor that is between 1 and 0. So if you'll observe dun sa image, nag-zoom in tayo. If you look at the scaling ng X and Y axes, lumaki yung 1 unit. So first, we'll apply a scaling factor of 1/2 or 0.5. So ma-observe natin na si negative 4, 1, si point A, napunta siya ngayon kay negative 2 and 1/2. So nag-multiply tayo ng 1/2 dun sa coordinates na negative 4 and 1. Ganun din dun sa remaining 3 coordinates nung pre-image. If we change the scaling factor to 0.2, liliit pa further yung image natin. Again, kung ang dimensions natin ay 2 by 3, magiging 0.4 by 0.6 kasi nag-multiply tayo ng 0.2 sa dimensions. At yung points natin, nag-multiply lang din tayo ng 0.2 sa coordinates. So from negative 4, 1, napunta tayo sa negative 0.8, 0.2. And you can check for the other 3 points na ganun din yung nangyari sa coordinates nila. So sa scaling, nagbabago yung dimensions nung pre-image papunta dun sa image by multiplying the scaling factor dun sa dimensions. Paano kung negative naman yung scaling factor na gagamitin natin? So since our mapping is xy dinadala sa k times x and k times y, pwede natin siyang isipin na kung ang scaling factor natin ay 2, edi dadalhin niya muna sa 2x, 2y, then kung gagawin mo ngayon siyang negative, mag-a-apply ka ng transformation na minus x minus y. So as we saw, when we discussed rotations, pag nag-apply tayo ng negative x, negative y na mapping, magkakaroon ka ng 180 degree rotation about the origin. So if we use a negative scaling factor, not only did we scale by yung absolute value ng scaling factor, which is 2. If you observe yung dimensions ng image natin, it's also 4 by 6. Pero may dinagdag pa tayong 180 degree rotation about the origin. Yun yung scaling effect sa dimensions. Kung 2 by 3 yung pre-image natin at nag-scale tayo by a factor of 2, as we see here, makikita natin na 4 by 6 yung magiging dimension ng image. Kung mag-scale tayo by a factor of 3, yung 2 by 3 magiging 6 by 9. Pero ano yung effect sa area? Kasi nag-scale ka both sa length at sa height or sa width. So how does that affect the area? Let's look at our pre-image here. The area is 6 units, 2 by 3. Kung nag-scale tayo by a factor of 2, magiging 4 by 6 na siya. Ano na yung area niya? The area is now 24. So, ano yung nilaki nung area mula pre-image papunta dun sa image when the scaling factor is 2? Nag-multiply tayo ng 4. 6 times 4 is 24. If the scaling factor is 3, so ang dimensions natin 2 by 3, naging 6 by 9. Ano na area ng 6 by 9? 54 square units. So, what do we multiply kay 6? Para makakuha ng 54, multiply tayo ng 9. So, if the scaling factor is 2, nag-multiply tayo ng 4. If the scaling factor is 3, nag-multiply tayo by 9. If the scaling factor is 4, ilan kaya yung multiply natin sa area ng pre-image para makuha yung area ng image under scaling by a factor of 4? Kung yung hula natin 16, that would be correct. Kasi Nagsiscale tayo sa length ng k. Nagsiscale tayo sa height ng k. The area is length times height. So, magsiscale tayo sa area ng k times k or k squared. To summarize yung pinag-usapan natin ngayon, scale transformations, they preserve shape. Pero syempre, binabago nila yung size ng image compared sa pre-image. So they don't preserve distance or size. When we say that we have a scaling factor of k, yung dimensions natin, yung namumultiply ng k. So a 1 by 1 square magiging 2 by 2. A 2 by 3 rectangle magiging 4 by 6. Kung ang scaling factor natin ay 2. If our center of dilation is located sa origin, then yung scaling transformation natin ay pwede nating i-represent by the mapping d sub k, or d just means dilation, k is the scaling factor, which maps xy papunta sa kx times ky. If k is between 0 and 1, this is a contraction. If k is negative, aside from the dilation or contraction na nagaganap, nagkakaroon tayo ng additional rotation about the origin na 180 degrees. And finally, speaking of the area of the image compared sa pre-image, pag nag-scale factor tayo ng k, ni-scale din natin yung area by a factor of k squared. This is the last geometric transformation na di-discuss natin. So after you go through the exercises on these, magsa-start tayo ng bagong topic. Babalik tayo sa graphs ng equations, or more specifically, polynomial functions. So, thank you and see you on our next meeting.